Hello everybody, welcome to this small post-mortem. So I'm working on a tool that is called split native array bytes through network. So it splits some native array in byte chunk and through those chunks on the network to be able to reconstruct on the other side. This is a small post-mortem, a sleepy one, where I just want to show a bit what I did. So here, for example, demo color 32. So we have here an array that is randomly generated over there. This array is invoked every second, and the idea is that it is stored in a deco storage, because the problem is that Unity, when you store a lot of data in the model behavior, the editor has some bug, so it's stored over there. So we can see here the reference of those chunks. So the idea is that the array you saw just earlier, it is split in some chunk. And that is a full array chunk. So it's all the array that I need to send on the network. Then it's split in small array. So for example, here, the first array here, it starts by some header that give you information on the reconstruction of those bytes. Then you have the information following beside. So what kind of information do we store? We store the array ID. So what is the ID to reconstruct the array at the end? The frame ID, that is what is the frame that we are currently building. I don't know why it's not incrementing. I suppose I left a bug. The chunk ID, so what is the ID of this chunk over there? And the idea is that I send all the chunk from the top to the bottom, because the idea is that when you arrive to 0, the other part, the client, need to reconstruct everything. But as it's something that need to be, you never know how many chunks you will send. For example, at start you can send 1 or 2 chunks, then 2, then 3, then 4. And so what you need to do is to be able to delete, to reconstruct on a bigger array. So the massive array is 31 chunk, but maybe at the start we want to send 1, then 0, then 1, then 2, then 3, then 1. So the chunk ID is used to be able to say, hey, if I'm at 0, it means that I receive everything. And that's the idea. So here you decide of what is the max element you want in your chunk, in your array, sorry. So here it's color 32. So as you can see, if you have this amount of color 32 sent, it will be around this number of bytes to send in total, and this amount per package. So a UDP package can send maximum 65,000 bytes. And so here you have the percentage used per package. So I can go upper, but going smaller allow me to manage a bit what I send over there. So yeah, that's 32 chunk to send if I want to send all those stuff. So that's the idea. So you have here the deco holding all those chunks that need to be sent. How do I generate those chunks? It's by using the splitter. So the splitter here is send a native array in this one, and I say, hey, I need some piece of 500 elements per chunk. Here is the reconstruction ID. I will need to reconstruct everything. Here is the maximum element I want to be able to send in those array. And here is the chunk that will be emitted every time I receive a native array. So I push a native array, it emits some bytes, and this is the chunk that will be useful to be reconstructed. As you can see here, it's taking less than 1 millisecond to do all the rest. So all that and the rest. So for the moment, we have this number of color 32 that are divided in split chunk and reconstructed at the end in 1 millisecond, over a bit under 1 millisecond. So here you can see it's sometime less, sometime 1. It's a lot. Maybe I can improve, but I'm already good here. So now that we have the splitter that is splitting everything, it sends it to the network over there, and as soon as it's sent on the network, it will receive over there. So I did not count in my computation here the number of times to send and receive the UDP, because I tried in another scene. that is more to try UDP and other system. So in any case, we'll take some milliseconds on the transmission of the UDP part to the other client. But here we arrive on the client part. Client part, he receives here some chunk of data, as you can see here. So you can choose here if you want what type of reconstruction array you want. So if I click 12, I will have all the chunk of the reconstruction array of 12. And it allows you to debug a bit if you receive correctly everything, and that's cool. Something that is very important is that if you want to check that your conversion is done correctly, you can do a verify strict over there. What is verify strict is that you just say, hey, I have 5 elements. Can you push it over there? And it will randomize and push it and see if your parser is correctly set. So if your parser here is correctly set, it will be correctly for the splitter and the reconstruction over there. So that's how I'm sure that here I'm receiving everything good. And so here I'm receiving all those parts. I need to reconstruct them. So I receive those bytes. I send them over there in the reconstruction debug. It's a static decode that stores reconstruction information. Once again, it's plenty of big data, and the problem is that those big data over there, do I have a debug? Yeah, I think I have a debug. I don't know why I don't have a debug. Reconstruction. I don't have a debug for it. I think I have one, but I don't find it. Okay, so I have the full data over there that are stored in a big array, and this big array will reconstruct all the elements based on the ID array. As soon as it's reconstruct, here it emits some notification that one of the frame is received. And when the frame is received, you have a conversion of the frame into a native array of bytes. Those native array of bytes, now that you have plenty of bytes one behind another that represents your structured data, it needs to be converted to the data. So here, as you can see, I take the data and I take the bytes and I convert it to core 32. So I take the byte I received, the big array, and I convert it back to the data in a native array type. And that's what you can see here. As you can see, I have some sampling. I don't know why it's not updating. Wait. Push array. I don't know why I have a bug. Okay, then I will watch to the other one. So that was Coro. I will check why it's not working. I will go on the integer. So we go back here. So push, poof, loop. We have all those information. Those information go in the splitter. The splitter split everything in some pieces over there. Those are stored here. As you can see, it's some chunk over there. Okay, the chunk is sent to the reconstruction. So as you can see here, to constructing everything in the reconstruction information that are stored in the static deco, just to avoid Unity to bug with the editor. Okay, those information, when they are built, are redirected here as the construction 11, array 11, to someone who knows how to take all those bytes and convert them back in the original format, that is an integer here. So this one, byte to native integer, will convert all this array of bytes to a native integer. And when you have those integer converted, you can see them back over there in a debug where you can just take the first one to check that everything was right. And here, as you can see, the conversion of 16k of element take less than 1 millisecond when it's integer. When it's color 32, it takes almost no time to, as you can see over there, because color 62 don't need a lot of conversion because it's basically 3 bytes 4 bytes, but I send 3 because the alpha is not interesting for me in this situation. And so here I can send an image of 100 of resolution, a bit more, but it's about 100 of resolution in less than 1 millisecond to the client side. So it means that not counting the lag between the start and the end, the server and the client, in less than a millisecond, I can send an image. It's super cool. And so that was the idea. I don't know why I have a bug on the here. I suppose it's a stupid stuff that I forgot to push somewhere, a script somewhere. I don't know where. But that's the idea. You can do it with anything, but you need to create some stuff. For example, I will show you here for the 32. So we push the 32 in the splitter. And the splitter, we split everything. But to be able to split all that, you will need to give me something. So all the clays are generic. I try to make it generic. So I'm asking you to give me the struct of what you need to push, a parser of what you need to push, and some randomizer to be able to generate all those testing side of the project. So for example, the randomizer look like this. So it's an interface that say, hey, give me what you want to randomize, give me the default version of this information, the random version of this information. Here, as you can see, I can optimize over there because I'm using system random. That is maybe not the best, but yeah. So that is the randomizer. Now we need to look at the parser, and that's the most important part. So we have a struct parts job over there. And what it does is that it needs to be able to convert some elements from bytes to information, and from information to bytes. So information to byte and byte to information over there. So I need those two, export, import if you want. Also, I need the random provider just to be able to generate all those information. So same that here. The difference is that sometimes I'm using just this one, and sometimes I'm using all the 3 one. That's why you have a double over there. But you can counter that by just calling the other one, calling the random. Oh, okay, that's not the point. Here we need to convert the information. For example, here we have a native array of bytes, and this native array of bytes is where you need to store the information that the user give us. This is a struct that will go in a job, and a job is a multi-threading operation. So the multi-threading operation will say, hey, here is the index of the current native array we are moving in. Here is the information of the elements you need to parse. And here is the native array where you can store it. And so here what I'm doing is I'm saying, hey, my element is taking 3 bytes, so I need to store in this at this offset the element size multiplied by the index. So now we know where in the byte we need to store it, and then I need to convert this in some byte. Here it's easy because it's color32 is stored on 4 bytes. So I take those bytes RGB and put it in a row, and ta-da! I have parsing of byte. Now I have parsing byte to element. So we take the byte over there and we generate the element. Once again, it will run in a job system. So the idea is that you can only use struct, and you need to try to find the best way to do it. Here, it's easy because we don't need to do conversion. It's just we take the 3 bytes in the good offset and we create the color that need to be created. So when you did that, it's super useful, because you just need to do this 2-1 here over there, and you can use my system to convert from one to another. You still need to create all those clays and all those stuff, but a lot of work is done for you. So the idea here is that if you can do those 3 stuff, then it will look like this. Why I'm doing this is because I'm doing a game over there that is called IMO SD, so integer massive multiplayer online shield drone. And in this, I need to send information about my drone, about some drone in my game, and send it to and send it to sorry, I try to look around because I'm looking about a code. I think I can look this one. So as you can see here in my game, I have some shield drone core information that I need to send through the network. So here I do a verification struct parser that will be able to me check if the conversion is correct. So for example, what it looked like here is that if I take this one here and I verify drone over there, okay, I say I want 5, I do parsing like this. As you can see, it takes those and pass over there, but you can see that there is something that is a bit weird. It's not the same exactly. So there is some difference between this number and this number already, and between this number and this number and this number and this number. They are close to each other, but they are not the same. Why? It's because a simple reason. If you look here, I have my struct up that look like this. So I have a boolean that say if the drone is connected, a collision who say if the drone is colliding something, a U short shield that represents does the player has a shield. The game go from this number to this number, but on the network I cannot afford to send those amount of information, so I will just send a byte. And on the player side he will lose some precision, but on the server it will be this precision. We have the position and the rotation, that is a quaternion. But the problem is that quaternion over there is for integer that are stored between -1 and 1. So how do I store a quaternion in a compressed information I need to send? Because it means that I will need 4 bytes multiplied by 4, so 60 bytes. 3 bytes multiplied by 4, so 12. So we are around 30 bytes to send those information. But 30 is not a lot. But when you have a lot of them and you need to send it to a lot of players, it becomes really heavy bandwidth. I don't know how we pronounce bandwidth. We have a lot of information to send to the player through the network. To give you an example, if you have 11 bytes, like I did, and those 11 bytes you send it to the network to 10,000 people, it's 11 multiplied by 10,000 people, and you need to send that like 4 to 6 times per second. 8 is the better situation. So 8 it means, yep, calculation. So we have 11 bytes for a drone multiplied by the number of drone, so this number in my game, multiplied by the number of people you will have to send it, because there is this number of drone, okay, multiplied by 8 frame, and that is the amount of bytes you need to send on the network. In the end, it doesn't mean that it is me who's sending everything, because I need to do a peer-to-peer or a broadcast system that allow you to allows this number of people, but that is a huge amount of bytes. So if I do not do 11 bytes but 30 bytes, I'm at multiply by 3. This amount of is still bigger, but it's very big. So that's a byte over there, not bits, bytes. So 1 byte, so it's kilobytes, megabyte, gigabyte, terabyte. So we go from 23 terabyte of data to 71 terabyte of data per second. So that's impossible. It's not what will be done It's just to give you an idea of why I'm doing my software. It's because I need to have something that converts information into byte and compress them with native array and then send them in small package. But I must not send all the package. So here, what's happening is that I have this that is compressing and splitting all the data in those amount of number. And in my other code, I need to add it to this one because it's not add yet, but it's easy to add. I have something that allows me to say how many players are currently connected. So if we have less than that, it means I just need to send one chunk of data. If I have more than that, like this number, it means that I need to send 2 chunks. Now if I go to this number, I need to send 4 chunks. So based on the number of players coming in the game, I will send the chunk that need to be sent on the other side. So instead of having this number over there, I will drastically low down this number based on the number of people connected to the game. More there are people connected, more the game will fail, and more we'll have to improve the system of the broadcasting system and the compression system and everything. But so the idea here is that I'm designing a tool that is done to split native array of information based on a big, massive multiplayer game on a single server. And I try to split those bytes to be through to the network. And that's what I'm trying to do. It's not super easy to do, but that's what I'm trying to do over there. And so to come back to the idea, if you want to use my tool, not to do a massive multiplayer, but just to send some information from a PC to another one, you need to provide a string parser job. And that inherit of that, you say, hey, here is the element size. So what is the size of this element that I want to send, to be able to split them in small pieces and not cut in the middle of one when you send the UDP package and others. Okay. And so here, same as before with color, but instead of color, we have a shield drone correct core information. And as you can see here, I'm playing with bytes. It's very, very important that you play with operation on bytes and not bytes, not byte convert, because byte convert take a lot of time. And most of the time when I use this, I'm at 30 milliseconds of conversion for 10,000 elements. And when you use operation like this, it take like 1 to 2, 3 milliseconds max. So you will have to work with operation byte. There is maybe a solution that allow you to go faster with unsafe code or with other system, but I'm not sure. So here we receive the drone, we say, hey, could you take all those information and parse them in some byte compression? And as you can see here, I have some operations that are a bit weird. The first one is the float array. Here I take the position of the drone and I convert them in 3 bytes. The 2 first bytes will be stored directly in the source offset, and the first one over there will be stored in another one that compress them. And that's what I'm doing here with drone state. So in drone state over there, we convert the boolean into bits in a byte. Same for collision. And with the drone state, we just take the 2. So how to explain that? So you have something like this. Up, like this. So this is the float when it's turned to an integer, and the integer is 4 bytes. So 1, 2, 3, 4. But the stuff is that we just want to keep a precision that is not the full precision, but just the first one. But that number is this amount of distance, and it's not enough. No, it's less than that. It's this number, and it's not enough for a game that I want to do. So to be able to go farthest, I take 2 more like this, and it's allow me to go to this number of distance in millimeter. And the stuff is that, yeah, but it means that I need to have new byte, but I don't need to have 3 bytes if I can store them on the same one. And that's why I do an operation to convert those bytes and say up like this, and the next one it will be like this, and the next one will be like this. And if you add all the 3 of them, you have this situation where you store everything in a drone state, and then you do it in the other way when you add the other side. For the quaternion, it's another trick. Maybe I will finish this one first, but float array here, what I do in a float array is just I take the float, I multiply by 1000, like that I have an integer instead of a float, and I convert this integer that is an unsigned integer. It's an integer, but it's an unsigned one. I turn them into 1, 2, 3, 4 bytes, like this. So I take the first byte, and then I do a switch of 60, then I take the second byte, and then I do this, and that's how you convert and have the 3 byte. And basically, I'm storing an integer in the network and converted it back later to recover it, as you can see here. For the Euler, it's the quaternion, it's a different story. Quaternion is 4 integer, and I cannot use 4 integer. So what I did is use bytes, and basically, when you're playing a game, the difference between 1 or 2 degree is not a lot. So if you have 4 degree, you start to see it. If it's 10 degrees, it's too much. Okay, but if you divide 360 by 200 like this, you arrive around 1.1 something, I don't know. So it's 1 degree precision if we keep just this number of degree. And for my game, it's not a problem. 1 degree precision is largely enough because the game will not use those precision. The server will compute on the real data, but the client, he just needs to have a visualization of what's happening in the server. So I just do a modulo to say, hey, we want to be between 0 and this number. Then we divide by this to have a percentage and multiply by this to have the byte converted by store it in it. Maybe there is a faster or better way to win some ticks in the countdown, in the compression, but for the moment is that. And like this, I convert my complex object that is a drone shield information in 11 bytes that I can store and send. And that's the idea here. It's just you have a compression and decompression that is fit to be set in a job system. What's happening is that I need to have something that compress information into bytes. Those bytes, I need to store them in the same big array. And the problem is that there is not something that allows you to convert easily some big information like this to some bytes without losing time or without going to the unsafe Marshall situation. And so that's why I'm using the job here for the moment, is this system. Maybe there is a better way, but for the moment I'm doing that. And the idea is that now that you have that, it means that you have a big native array with all those information in it. And you need to chunk them in small pieces. And that's what I'm doing. So you saw how we parse. Now how do I chunk? Yep. Here. I will go here. So here what's happening is that I receive a native. I start counting time just for the information. I set the job, I chunk. Set the job is what I did with you. So if I go here, I receive the native array you want me to parse to the network. I send that to the job system over there, and I say, hey, here is a big part of an element, and here is the native array of byte I need you to store all the information in. Max element is how many elements we want to be parsed in the system, because if we go here, as you can see, I can say, hey, I have a max element here, so if it's over it, don't do it. And so I need to add something that say, hey, I'm sure I add it, but not in this version apparently. Hey, if you go over that, you don't need it. So here, it could be the player base of your game, if you want the game to scale, if you want to use it like me for a game. So that is the set job system that will take the stuff and convert it. I show you back in case you need. So we take the native array, we put it in a job, we say here is the element, here is the byte we want to create, the big byte array I call it, and here is the parser, so the struct that know how to parse them. Because the problem is that in job system, it's something that is sent on the thread, and on the thread you cannot send a reference or just an action or a delegate. So you need to send the method as it's built in the struct. And that's why I'm doing here a system with I have the element and the parser in the struct. As you can see here, I have this, and this is a struct. So it's a struct who know the method how to parse. I give it to him and I say, hey, could you parse it? So that is how we do it. Handle will do the job, and here I'm saying, hey, do it all, and wait to complete and go to the next part and add a chunk frame. Stuff here is that that's not the best way to do it. So this is one way to do it. Another way I could do it in the future is to not complete it, but queue that, and as soon as a part is done, send it to another one that will compute, and instead of having some layers of information, I could do a stream on the information. But I don't have the level now, I want to have something working, so I will not do a stream on the information, but technically I could work on a stream of chunk of bytes, and that would be wonderful. But for the moment, it's this situation. So that is the native part. If you give me an array, I will just do a native temp here, and then set it, and then dispose of it. Because in a version of where I'm testing, I'm keeping those information, but in this one, I'm just having the information, and I don't care if you destroy it after that. So set job to root, I received that. Okay, now that I set a big array, I need to prepare this array. So as you can see here, I have the full byte array, that is a native array, and I can to array it, and to array it, it will just copy the memory of the native array, and it will put them in a byte array. And that's why we need a big byte, because I'm parsing everything on it, and as soon as it's done, we can copy memory byte. And that's very important, that's why I'm doing that. This big byte, now that it's only byte, and that's why I'm doing all this parsing with job system, we will be able to buffer them. So we take a big part of the memory and we copy it. So it don't need processing or computing or copy pasting. It's just we take the memory and poof, we put it away. There is maybe another way that is unsafe or Marshall way that is faster than this one, but for the moment I have this one. So for all the chunk, I need to parse all those information in chunk that I will copy in a chunk array. So I will take the full byte, copy those, and prepare them in some small space that is reserved for them. Because you don't want the garbage collector to come and destroy your performance every time. So you need to prepare the data and put them in the memory and never change it. So that's what I'm trying to do here. So I'm copying some information from database to database, if I can say. And that's what I try to do here. So now that we copy all that over there, then we can say, hey, send it to whoever is listening to be able to parse it. And so that's the idea, basically. That's a bit of the idea. So that was the splitter over there. That's what's happening here, over there. And yeah, maybe something I can do is TDD, show you what it looked like before. So before I was doing that, it looked like this. So you have your information over there, 222, that you want to parse. And you have the holder over there. Up, refresh. Yeah, it won't work because I need to refresh it. But the idea is that you have your color over there. Your color is initiate over there, and it will be parsed in a full array of data. And yep, you will have some chunk of data over there. And those chunk of data, as you see before, is just some stuff over there. And the reconstruction one, maybe I can, with a bit of luck, because I wanted to show you the reconstruction one, but I don't know why I cannot show you. It's not a problem. The video is already too long. But that's the idea. So basically, if you need to have a tool that take a native array of elements and send it to another computer quickly on the network through UDP, any network that is allowing a chunk to be sent in bytes. Basically, it's not just UDP, it's any stuff that can send chunk of bytes. But if you have a PC that need to send a big native array to another PC through network, this tool is very useful because it do it quickly. Is there a way to make it faster than what I'm doing? Maybe. All I can say is that I'm using the job system of Unity to do that and copy memory, so it's already really fast. Another way to do it faster would be to use compute shader, but the problem is that I'm always stuck between, do I use job system to go fast and not have a headache every time I need to convert data, or do I use the compute shader but I need to use only maths, and there is some stuff that are impossible to convert in the compute shader. So there is some possibility to go faster with the compute shader in some case, but yeah. So yeah, and if you want to send an image, this one is the color32, so you can do it with the color32. And here I'm using some random information, but you can also use under texture. Yeah, I won't show you, but basically I have a version of this that take just the render texture and convert it to a native array of color32, so you can easily send an image through network with this system. So I'm kind of happy to be able to do that now. But it still takes some time. So color62 is converted, as you can see here, I'm doing like this number of color32, and this number is for this number of resolution. But the stuff is that when you go for Kinect, for example, Kinect is this number of resolution, so it would be this number of color32 sent on the network. This one is taking less than a millisecond, but it means that divided by 6, it will take like 10 milliseconds to convert a Kinect information and send it to the other side. 10 milliseconds is not a lot, but it's already too much for a game. So if you need to do that anyway, then what you need to do is to take all those information, convert them into a big byte array that you put in the memory of Unity of the Windows computer, and then you take those memory outside in a second application and you push them through the network, just to avoid having a bad frame rate in your game. to avoid having a bad frame rate in a game because you're converting the Kinect part. I need to do that, but did not work on it because that's a post-mortem I'm doing here. Is something that I'm doing before continuing on another topic of the project that is still linked to that, but that's maybe this part. Because the stuff is that you want to have a game that runs really fast, but you also want a game that is not taking an eternity. And the problem is that I have in my case, I have this number of drones flying around, and it means that I need to check the collision with this number of drones flying around. That's a lot of possible collision. So my friend is working on the oak tree, and I will have to work on other system of collision, but it means that I have some collision system that need to be created on drone, but I cannot put that in the game because this game over there need to run at 60 FPS or 40 FPS. And if it need to run at 40-60 FPS, this number of computation will have to be outside of the game, so on another computer. And that's why I'm doing that. I can share, do a memory share on the PC. So memory share file is a file that you put in the memory of the PC instead of the hard drive, and then you extract it in the other application and then you read it. And that's why in the splitter here you have a chunk part and a byte part, because if you want to chunk it, you can put it here and it will be chunked to the network. And if you want to have a memory file in the RAM to share the information from an application to another one, then you don't want to chunk it over there. You want to take those bytes and put them in the memory system directly. And you don't need to chunk it to put it in the memory system, but to be able to have this full byte, you will still have the job system that need to parse all your elements in some byte. And so the system I'm doing here is also if you want to not chunk it, but send it in a big file through something. That's also something that is pretty cool to do, that I still need to prove is working over there, but because I did it for the Kinect in the past, and just now I need to redo it and check if it's still working, but that's the idea. So yeah, that was a very long post-mortem of what I did over there. You can find the code on GitHub. It looks like this, and you will have to use another one at least. So if we look at the assembly, we have the bus system of Unity that is using the job system, and we have watch because it allows me to compute the number of seconds that is going from one process to another. And you will need the static deco storage mono, because as soon as you store a lot of information in the editor and inspector of Unity, it makes some slow, very big slow because of Unity editor. And I don't want to have that, so what I'm doing here is that I'm storing all this information in a big static array that is using deco to be able to find back the information. So you will need to use that if you don't want some slowdown in your editor. And so yeah, hope you have a beautiful day. May the code be with you. See you next time. Feel free to ask questions on the Discord if you arrived to the end of the video. If you need those code, feel free to ping me. If you can understand it, good for you. Just use the code and ta-da. If you cannot understand it, feel free to hire me to teach you how to use it and check around if we need to modify the code. But yeah, have a great day. See you in another video. Bye.